Exercise 6, PERT distribution. Place your cursor on cell B58 and click on the Define Distribution button. The following palette window appears. Choose a PERT distribution. The following window appears. Click on the parameter 3-dot button on the left-hand side of the window and specify Excel references option. Click on respectively B59, B60, and B61 cells to insert parameter references for the minimum, most likely, and maximum parameters. When done, press on the upper right-hand side corner of the small window to return to At-Risks window, which will now look like this. Now we step to compare a triangular distribution overlaid on top of this PERT. Use the Overlays button at the bottom part of the distribution window to place an overlaid chart on top of the previously created one. You can overlay additional distributions on top of the previously created one for viewing and comparing purposes. We will now create an overlaid triangular distribution to compare both distributions. Click on Select Distribution for the triangular and the following chart appears. Observe that the parameters for the overlaid triangular, depicted here with the red distribution function, are somehow inherited from the previous PERT distribution. They are the same parameters: minimum, most likely, or mode, and maximum. Now, we repeat the steps to change the hard-coded numbers for the parameters of the triangular distribution. Click on the parameter 3-dot button on the left-hand side of the window and specify Excel references option. Click on respectively B59, B60, and B61 cells to insert parameter references for the minimum, most likely, and maximum parameters. When done, press on the upper right-hand side corner of the small window to return to At-Risks window, which will now look like this. By dragging the right delimiter, the vertical line on top of the chart, above the 90-minute value on the x-axis, observe how much probability, area under the curve, lies beyond according to each one of the two distributions that share the same three parameters. Observe that the triangular distribution assigns close to 29% probability of an outcome larger than or equal to 90 minutes. On the other hand, the PERT distribution only assigns close to 9% probability at this mark. In other words, if the driver considers that he is arriving late to work after 90 minutes, then the triangular distribution would impose such an outcome on close to 3 out of 10 possible days, whereas the PERT distribution would only assign such an outcome on less than once every 10 days. In other words, the triangular weights as much as 3 times the tail of the distribution at points beyond 90 minutes. The triangular distribution has these desirable characteristics. 1. It is relatively easy to specify. And 2. Even if it overestimates the extremes, if not significantly overestimated, it can then be considered as a conservative distribution. The more biased a distribution, this triangular one, will tend to have tails that are fatter than the PERT. The analyst should decide which distribution best describes the behavior of the tail. The triangular distribution has these deficiencies. 1. In cases where there is a very small possibility of an extreme event, the triangular will tend to overestimate the probability of an extreme result in this case. 2. Assumes linearity of the probability density function. We tend to prefer the shape of a PERT distribution, which assumes that the predominance of the results occurring in the most probable range, and then the tails are rounded. In other words, a triangular distribution creates a mathematical discontinuity at its peak or mode, something that the PERT avoids. The difference between a PERT and a triangular distribution becomes even more so critical whenever there is asymmetry present. Temporarily modify both most likely parameters for the PERT and its overlaid triangular and write 90 as its value. 90 is the average between 50 and 130, respectively the minima and maxima of both distributions. Therefore, this will temporarily create two symmetric distributions. Now, move your right-hand delimiter to an extreme data point such as 120. The two probability values at the right extreme tail become more similar, 1.6% and 3.1% respectively. Change back again the values of the two most likely parameters to the B60 reference. Click OK to exit this chart, saving the last changes we made to this cell. Thus, when distributions are highly asymmetric, the usage of the PERT or the triangular might render very radically different probability outcomes at the tails of the distribution. In many real-life cases where distributions tend to be asymmetric, such as time and cost and project management, you should be careful on which distribution to choose. A rather different algorithm will follow, where we show a method that focuses on the tail of the distribution, not necessarily the minimum or the maximum, in order to create a better distribution.